Thank you. And thank you all for being here, because it rarely happens that I can talk to fellow researchers about something else than everyone's favorite topic, content of 90% of academic discussions, aka funding. No, funding is really not a good idea, because we physicists tend to get our money in a very unorthodox way. For example, when my specialty, gravitational physics, was almost eliminated in the 60s, we survived by getting ourselves hired by the US military under the condition to develop anti-gravity weapons. You can imagine how this went. We realized that if we store the generals with some science mumbo-jumbo, we can just continue with our normal experiments. Using their money to refine our technology over many decades, we arrived recently at a detection that was a bombshell in the field of physics, therefore completely bypassed by the average population. The Nobel Prize 2017 for gravitational waves. So let's get somebody to tell us what these things really are and why they are so special. Inventor of the theory of gravitation and universal genius Albert Einstein says gravitational waves are not existent. Yeah, that's not too helpful, and was a bit of the reason why it took us over 100 years to finally detect them. So let's try to figure it out ourselves, okay? Gravitational wave, this is a wave of the gravitational field, okay? Propagating through empty space at the speed of light and caused by an accelerated mass. Okay, waves is something which we all know, right? Water waves especially. If we throw a stone into a lake, we see these little ripples on the surface. But what does it mean by caused by an accelerated mass? Well, let's put a mass into our lake. For example, a duck. Well, this is just sitting there and not really moving. So in order to change this, to make it accelerated, we put a second duck, female this time, into our lake. And then the following happens. The male duck will slowly start to circle around our female duck, and she will do something similar. And as they do so, we will see little ripples, when we stay at the shore, coming to us, caused by their paddling. And over time, as they get closer and closer together, the ducks get more and more nervous, the waves we see get stronger and stronger. Then at some point, when the ducks are very close together, the male duck makes a jump onto his beloved female, and yeah, we see a huge spike in our wavefront, and afterwards maybe some faint rhythmic vibration, but I have really no idea why. What you've seen right now is what we call in physics a merging process. And not just any merger, but a black hole merger. These are the original data taken by LIGO on the 14th September of 2015 of the merging of two gigantic black holes. Yeah, LIGO at the Louisiana State University. These are two gigantic pipes, 4 kilometers in each length, with mirrors at each end. Between these mirrors, we send a light beam back and forth, an accomplishment in itself, because these mirrors, as I say, are 4 kilometers in length. If our gravitational wave hits these mirrors, it dispatches it minimally. The light beam takes minimally longer, and we physicists can compute how strong the wave was. I keep on saying minimally, because albeit black holes being gigantic, several dozen of sun masses, the waves we see here are really, really small because they are so far away. In the case of the first detection ever, the mirror was displaced by the 1,000th part of the diameter of an atom. And yes, we could really measure this. A word of caution, so no one goes home with a wrong idea. There is a difference between black hole and ducks. Namely, after a merger, two black holes will never again separate, which is a bit boring, right? These waves are therefore of a blink it and you miss it character. But in order to understand if our universe also hosts other sources of gravitational waves, we have to ask again this guy Einstein and ask him about the universe. So the universe is like a raisin bun. This isn't as stupid as it sounds at first glance. Imagine the stars to be the raisins and the empty space, this is the yeast dough between the stars. So Einstein's equation tells us that the raisin bun is currently in the oven. The heat causes the yeast dough to expand, and therefore the distance between the raisin grows constantly. Fascinatingly, this is exactly what astronomers see nowadays. the stars appear all to be running away from us. Well, not really from us. The distance between all objects in the universe grows constantly. Because the yeast, though, empty space itself, is expanding. But then, at some point, another physicist came along, Stephen Hawking. He concluded, if the universe is expanding at the moment, then earlier one, it must have been smaller, much smaller. A tiny speck. At the beginning, it must have been a single point in which the mass of all stars was infinitely dense, concentrated. And this single point gave suddenly rise to our universe, the Big Bang. But big being a commercial trick of physicists, because we like to put fancy names in front of our inventions. Ultra-cold atom, supernova, Big Bang. Although it was in reality not very big, but really, really small. However, with objects that are really small, rules apply which are completely different than what we know. For example, with electrons and atoms, or you know Schrödinger's cat maybe, which is sometimes dead, sometimes alive, and sometimes both at the same time, if nobody's watching. This is strange and inconceivable for us, and not just for us. Einstein himself could, until the end of his day, not believe at the quantum nature of the very small things. Therefore, his theory is completely wrong at the point where the universe was very, very small. Yeah. Due to computations from these quantum theories, nowadays some physicists believe that before ours there was an old, ancient universe, contracting since eternity, becoming very, very small. But as it was so small, a repulsive pressure caused by quantum gravity kicked in and inflated the universe again. And there we are today. Yeah? Not a big bang, but a big bounce. Well, of course, this is an unproven theory because no one of us has a miniature universe in his basement in order to test this hypothesis. But there might be a way to verify it soon, the gravitational waves. If this old universe is really existent, then back then, black holes could have collided, caused gravitational waves, the only thing which could travel through the bounds to us, and maybe perchance being detected at some point. And who knows? Maybe an ancient civilization existed back then, sending gravitational wave signals as messages to us in our universe. Well, if I look at the night, up at the stars, these are the questions pondering in my head, and I hope from now on, yours as well. Thank you a lot.